Today I'm going to show you how to answer a few questions from a packet you did a while ago. It looked like this. It was called Lesson 2.4, What's Energy Have to Do with It? You may have it with you. You handed it in and got it back if you completed it. And I'll just scan through to show you what it looked like. We're going to focus today on this question 6. This question 12, this question 15, 16, and 17. And there's a document attached to this assignment as it's posted on Google Classroom, and it looks like this. And it just has those questions taken out of the original packet and then some energy tables for us to fill in. So we're going to start here with number 6. I suggest that you take a look at this question yourself, maybe try to fill in the table on your own before watching the rest of this video. In this problem, we're trying to find an expression for the marble's speed at point 2. So that would be whatever goes in this box. In terms of H1 and H2. So those are the two variables that come from the problem that are in all of these options that we'd select for. So like the work we did today, we're going to go through this problem and we're going to fill in the things that are given to us in the problem. What's different about this problem is that we're given letters, not numbers. So our height at point 1 is H1 here. Our height at point 2 is H2. I'm going to fill in numbers for point 3, even though it's not super necessary because point 3 isn't really discussed in this problem. But my height at point 3 is 0. And then we're also given that velocity at point 1 is 0. And then at point 2, our velocity is v2, although we're not actually sure what that is. It's an unknown. And at point 3, our velocity is v3. So now we go through this problem and we calculate any energies that we can calculate. So my GPE is mgh1 here at point 1. It's mgh2 at point 2, and it's 0 at point 3. My kinetic energy is 0 at point 1 because my velocity is 0. It is 1/2 mv2 squared, although we don't know what that is over here. And it's 1/2 mv3 squared here. We also don't know what those are. They're not given to us. So really, when we did problems like this before, we left this blue box blank. Because that information isn't given to us, we're going to have to figure out what goes in that kinetic energy using our mechanical energies. So let's fill that in next. So our mechanical energy at point 1 is just this GPE plus this KE. So that's just mgh1. And you'll remember from the step-by-step instructions you did today that whatever we get as mechanical energy in one box, we fill in all the other boxes. So mgh1, mgh1. So you should also remember from the step-by-step instructions today that when there's a blank energy like what I highlighted in blue, we can calculate that by subtracting our GPE from our mechanical energy. So my total energy is mgh1, so that means that these two things that I'm highlighting in green should add up to this total mechanical energy that I'm highlighting in pink. So that means that what goes in this box here should actually be what's in pink, mgh1, minus what's up here in green, mgh2. So that tells me that what I have in this blue box, 1/2 mv2 squared, is equal to mgh1 minus mgh2. And now I'm just going to solve for v2. So I can cancel out all my masses. I can multiply both sides of my equation by 2. That gives me v2 squared equals 2gh1 minus 2gh2. And then I square root v2 equals the square root of 2gh1 minus 2gh2, and that is B. So now we're going to move on to the next problem. So this is asking what factors do not affect the speed of the marble at the bottom of a ramp. So it's describing a ramp where a marble starts at rest here and rolls down, and we're wondering what this velocity depends on. So at point 2, our height is 0. At point 1, our height is h. At point 1, our velocity is 0. At point 2, so here our GPE is mgh, our kinetic energy is 0 at point 1, so our mechanical or total energy is just mgh, and we write that in both places. Our GPE here is 0, so this here is going to be what's remaining to make mgh our total energy. So that's going to be mgh minus 0. So mgh. So now we can use this to find an expression for velocity. So mgh is our kinetic energy. That's equal to 1/2 mv squared. We cancel out our m's. We multiply both sides by 2. That leaves us with 2gh equals v squared. We square root both sides, and so our velocity is the square root of 2gh. So that means it depends on the strength of gravity, it depends on the ramp height, but it doesn't depend on the marble's mass, because you'll notice that we canceled out the m's because there's a mass on both sides of this equation. So now we're going to do question number 15. You roll a marble up a ramp, and we're going to develop an equation for H2 in terms of V1 and G. So H2 is the thing that we want. We want it in terms of V1 and G. Our height at point 1 is 0, so is our GPE. Our kinetic energy at point 1 is 1/2 mv1 squared. So our mechanical energy is this kinetic energy plus our GPE, so that's 1/2 mv1 squared. We put that everywhere on the bottom row of our table. Our velocity at point 2 is 0, so this is 0, 2. So what goes in this GPE box is whatever it needs to be to make our total energy still equal to 1/2 mv1 squared. So that would be 1/2 mv1 squared minus 0. So what's in that box that I just highlighted, plus this kinetic energy, should give us our total mechanical energy. So now my GPE is equal to 1/2 mv1 squared, and that is also equal to mgh2, so I'm going to use that to solve for h2. So I can cancel out my masses. I can divide both sides by g. And then I'm going to be left with 1/2 v1 squared over g is equal to h2. And then that is our expression for h2. Next, we're going to do problem number 16. We're looking for an equation for V3. So that's our unknown. In terms of H1, so that's a known, V1, so that's a known, and G. And then we also know H2, and we know that the height at point 3 is 0. So we're going to start with the first column for point 1. So our GPE is mgh1. Our kinetic energy is 1/2 mv1 squared plus mgh1. Nope. Sorry, that was a mistake. It's just 1/2 mv1 squared. And our mechanical energy is mgh1 plus 1/2 mv1 squared. So both of those added together. And we're going to take that mechanical energy and we're going to fill it in for the entire final row. And we don't know what this velocity is for V2, but we don't actually need to because none of this problem is asking us about point 2. So we don't really have to worry about it. But we do know that the GPE at point 3 is 0. So we know that the kinetic energy has to be whatever makes this GPE plus this KE equal to this mechanical energy. So that would mean that this kinetic energy is mgh1 plus 1/2 mv1 squared minus 0. So what I put in this box is just mgh1 plus 1/2 mv1 squared. And so since that's equal to my kinetic energy at point 3, it's equal to 1/2 mv3 squared. So I'm going to set up that equation. I can divide both sides by m to get rid of all these masses. I can multiply both sides by 2 to get v3 squared equals 2gh1 plus v1 squared. And then I can square root both sides so that my v3 is the square root of 2gh1 plus v1 squared, and that's my final answer. And then finally we're going to do number 17. Number 17 has this little L4 next to it showing that it's an especially challenging problem. So if you want to focus your attention on understanding the other problems that we've done so far instead of continuing this video, then that's fine. If you want to challenge yourself with something a little trickier, then keep watching. So in L4 we have two different situations. And that means that whatever our mechanical energy is over here for our first situation at point 1 and point 3 is going to be different than our mechanical energy over here for point 4 and point 5 because they're completely different ramps and experiments. So we're looking for H4, and we're looking for it in terms of H1. So that's what goes here, is H1. And then at point 3, our H is 0, as is our height at point 5. And since we have this height table, but it's the same for both situations, since these heights of the tables are the same, we can just set that our height equals 0 starts at the top of the table. So now our GPE at point 1 is mgh1, because h1's given to us. Our velocity is 0, that's given to us too. So our kinetic energy here is 0, and our mechanical energy is just mgh1, and we can fill that in here too. And at point 3, we don't know our velocity, but in the problem, it does tell us that V5 equals 2 times V3. So I'm going to put that over here. V5 equals 2 times V3. And so here our GPE is 0. H4, we don't know what that is, but we do know that our velocity there is 0. And so that's 0. And then we don't know our V5, but we do know that our GPE is 0. And then we know that this is 1/2 mv5 squared. We know that this is 1/2 mv3 squared. We know that this is mgh4, but we don't actually know what h4 is. And then we know over here that this is 1/2 mv5 squared, and this is 1/2 mv5 squared. So now we're going to have to set up some systems of equations to solve. Over here, we know that this GPE plus this KE gives us this mechanical energy. So I'm going to write an equation over to the left. 1/2 mv3 squared equals mgh1. And then we know that this GPE plus this KE gives us this mechanical energy. So we know that mgh4 equals 1/2 mv5 squared. So now I'm going to have to use this information over here, that V5 equals 2V3, to replace this V5 in this equation because I have too many unknowns. So I substitute in 2V3 and I square that, and when I square that, both the 2 and the V3 need to get squared. So now I'm going to distribute that. And then I'm multiplying this half and this 4. So now I have these two equations. So now I have these two equations, but I need H4 here in terms of H1. So I need to get rid of V3 here and here. So I'm going to use this equation to get an expression for V3, which I can then plug in here. So I'm going to cancel out the m's on both sides, and I'm going to multiply by 2 on both sides. So I've got V3 squared equals 2GH. And then I'm going to take that V3 squared and I'm going to plug it in and replace it here. I'll put it right here. So mgh4 equals 2m times 2gh. I'm going to cancel out the m's again over here, and I can also cancel out the g's to get h4 equals 2 times 2 times h1. So h4 is 4 times h1.